Hello students, so today we will discuss about allotropes of carbon. So first of all, what is allotropes? So when single atom forms different type of bonds with the same type of atoms to create different type of molecules, they are called allotropes. As for example, when two oxygen atoms combine with each other to form dioxygen gas, and similarly when three oxygen can combine with each other to produce ozone. So oxygen and ozone, both of them are allotropes of oxygen atoms. So similarly, as we discussed in previous point, carbon has catenation property. That means it can form multiple bonds with itself, and that's why we have many different type of allotropes of carbon. Some are naturally known and some are artificially made or made in laboratories. We already know graphite is a pure form of carbon. Similarly, diamond is also pure form of carbon, but they vary in their properties. Diamond has extremely strong properties and strength. On the other hand, graphite is a soft material. Diamond is non-conductor of electricity, graphite is conductor of electricity. So although both of them contains only carbon atoms in them, still they have completely different properties from each other. Similarly, we have one more form of carbon known as fullerenes. It was discovered by H.W. Kroto, E. Smalley and R.F. Kerr. So, because of the discovery of fullerenes, these scientists won Nobel Prize in 1996. So, first of all, let's discuss about the diamond. So, diamond is hardest compound on earth. If we talk about natural compounds, artificially we have more hard compounds than diamond, but naturally occurring diamond is hardest one. So, first of all, let's understand what is hardness. So simply hardness can be described using numbers. So diamond has hardness equal to 10. So for natural compounds, 10 is the maximum hardness. We have lab synthesized material which has more hardness value than 10, but let's talk about the natural compounds in this case. So diamond is on number 10. So what these numbers mean? So let's say if you have number 4 hardness in the compound A, and we have second compound B which has hardness value equal to 6. So if we use number 4 material to scratch number 6, then we cannot scratch B using A because it has more hardness, but we can scratch A using B. Now let me be more specific. Usually metals have hardness ranging from 4 to 5. That means daily used metal by us, as for example iron or copper or steel. Their hardness range is between 4 to 5. And for glass, hardness range is 6 to 7. That means glass are more hard than metals. And this is the reason you cannot scratch your mobile screen using knife or coins or keys, because glass has more hardness than the metals. But we can scratch metals using piece of glass. But it doesn't mean glass are more stable than metals. If you have hammer and if you scratch it on the screen of mobile phone, then you cannot scratch the mobile screen. But if you hit screen with the hammer, then screen will shatter and hammer won't, because hammer has flexibility. It can flex, and that's why it can distribute the impact, and that's why it cannot break easily. On the other hand, glass is rigid compound, it is not flexible, that's why it will shatter. So hardness and strength, they are two different things. Metals are stronger, but they are not hard, they are comparatively softer than glass. So it simply means although diamond has hardness value equal to 10, which is far more than metals, but still with the impact of hammer we can break the diamond. All of the carbons in diamond are sp3 hybridized. That means each carbon is attached with 4 other carbons, and that's why all of the 4 carbons attached with the center carbon will be aligned tetrahedrally. So that's why they create a grid, 3D grid like pattern as shown in this image. Let's say if we consider this carbon atom, then as we can see it is attached with 1, 2, 3 and 4 other carbon atoms. And all of these 4 carbon atoms are present at the corner of tetrahedron. That means they are tetrahedrally attached with each other, and all of these carbon will follow the same pattern. That means they will create tetrahedrals all along the three-dimensional arrangement. Each carbon-carbon distance is 154 pm. That means bond distance is 154. And all of these bonds are covalent bonds, and that's why it is very hard to break. If two different molecules are attracted towards each other, then attraction is easy to remove. And that's why we can easily separate them or easily break the bonds. But if two different atoms are permanently bonded together using covalent bonding, then these bonds are very hard to break. And because of that, diamond is hardest natural compound because it has all the covalent bonds in it. We can understand it like this way. Suppose we have 1000 carbon atoms in a bunch of diamond. Then all of these 1000 atoms are attached with each other via covalent bonding. That means all of these 1000 carbon atoms behaves as single molecule. They have permanent covalent bonding with each other. And it is the reason why diamond is hardest thing naturally occurred. Now on the other hand, second allotrope of carbon is graphite, which has comparatively softer nature and it is conductor of electricity. On the other hand, diamond was non-conductor of electricity and it is hardest natural thing. In graphite, we have multiple different two-dimensional layers of carbon atoms attracted towards each other. Two different layers have 340 pm distance between them, and all of the carbon in graphite are sp2 hybridized. So this is the main difference why carbon in graphite form and carbon in diamond form have completely different properties. Main reason is their hybridization. In diamond we have sp3 hybridization and that's why tetrahedral arrangement. In graphite we have sp2 hybridization, that's why arrangement of carbon around the central carbon will be planar triangular. As we can see in this image, if we observe this carbon atom, then it has three other attachments, and all of these three carbon attached with center carbon are present at the corner of planar triangle because the center carbon is sp2 hybridized, and all of the other carbon in this layer and following layers will follow the same trend. Because of that, they will create planar structure as we can see here, and this planar structure will be attracted towards each other because one unpaired electrons. If we check the electron arrangement in diamond in carbon, as we can see in excited state of carbon, carbon has 4 unpaired electrons and all of these 4 electrons will pair up with electrons of other carbons, and each carbon will provide one electron. And as we can see, because of that we can get electron precise compound which has all the electrons used in bond formation, no empty orbitals, no non-bonding electron pairs. Because of that, carbon has strong in this case carbon has strongest properties and it is non-conductor of electricity. But if we talk about the graphite, then graphite forms three bonds with three other carbons, and that's why last electron will remain unpaired, and all of the properties of the graphite is because of this last unpaired electron. Which properties? So as mentioned, it can conduct electricity. Graphite is conductor of electricity because for conductance we need two different things. If one of them is present, then compound can conduct electricity. First, we required unpaired electron. If compound has unpaired electron, then it can conduct electricity, or compound should have free ions. If compound has free ions, then it can conduct electricity. In this case, we have unpaired electrons. Because of that, graphite is conductor of electricity. Second property of graphite is because of these unpaired electrons, each carbon has one unpaired electron, and that's why all the carbon present in layers has at least one unpaired electron. Similar trend will be observed for bottom layer. So this unpaired electron will feel attraction towards each other, and this is the reason why these layers of graphites are attracted towards each other. Because of these unpaired electrons, both of the layers or multiple layer feel attraction towards each other, and that's why they will stack up on top of each other. But this attraction, as mentioned here, they are van der Waals attraction. So that's why they are not permanent bonding, and because of that, these layers can slide on top of each other. Because they have empty space or cavity between each other and they are not permanently held together, it will create slipperiness, and because of this slipperiness, graphite is soft material. This is the reason why we can stretch a line using the graphite, because graphite is used in pencil on the paper. And because of this slipperiness, graphite is used as dry lubricant or solid lubricant. Lubricants are material which reduces friction. In our vehicles, we use oils to reduce the friction. That's why we use oil lubricants or liquid lubricants. But if conditions are extreme, that means if machineries creates extreme temperature, then we cannot use oils, because with increasing temperature, lubrication property of oil reduces, or viscosity of oil reduces. Viscosity, that means thickness of liquid. With increasing temperature, thickness of oil reduces, and that's why it reduces the lubrication property. So if extreme high temperatures are there, then we cannot use oils. But in that case, we can use graphite as solid lubricant. Graphite powder can reduce the friction without without being affected with temperature. As for example, in carom board, we use powder to reduce friction. Because when friction is increased, pieces won't slide easily on the board of carom. That's why powder will be handy. The other allotrope of carbon is fullerene. Fullerenes have many different type of innovative properties. They have many innovative uses as well. But right now we are on basic level, that's why use of fullerene is minimized. But in future we can use them in multiple different type of scenarios. So fullerenes are made by the heating of graphite in electric arc in presence of inert gases such as helium or argon. So first of all, what is electric arc? When we place two metal rods close to each other and when we pass high voltage of electricity through them. Now keep in mind, two electrodes are placed close to each other, they are not in contact with each other. In that case, when passing high voltage of electricity, electrons will try to flow from one electrode to other, but because they are not in contact, they need some medium to transfer the electron, and that's why they will use air molecules present between them. Air molecules will ionize because of electrons and they will become conductor. During this process, very high temperature will be produced, and because of this high temperature, air molecules will start glowing, they will start producing light, and it will appear like thunders or lightning in sky, because both of them are same thing. In lightning, same thing is going on, air molecules becomes ionized and they becomes plasma, and we know it as lightning. In this case, because of very high temperature, even metals will instantly vaporize. We know that metals have very high melting and boiling points, but in case of plasma, they will instantly vaporize. And same thing will happen with graphite. Here we have example of this type of electric arc. Two different electrodes are in placed close together, but they are not in contact with each other. And because of that, air molecules present between them are ionized, and this is example of electric arc. But heating graphite using this method, we should keep in mind that if air molecules, normal air molecule, that means oxygen or nitrogens are present, then they simply will combine with carbon to produce carbon dioxide gas. To prevent that, we need noble gases. But at the same time, we need something to conduct electricity, so that's why these gases are present. Otherwise, we can carry this practical in vacuum, but in vacuum, no conductance of electricity will be observed. So because of this very high energy, instantly graphite will vaporize. The sooty material formed by the condensation of vaporized carbon or graphite
will condensed in Cn small molecules. That means multiple different carbon molecules will combine with each other when we condense the soot of this graphite. So this mainly contains C16, that means 60 carbon atoms in single molecule with smaller quantity of C70 and trace amount of fullerene consisting of even number of carbon atom up to 350 or above. So that means you will get mainly C16 as a fullerene and multiple different type of other fullerenes mixed with it. Here is the example of C16 fullerene, that means it contains 60 carbon atoms. It is also known as Buckminster fullerene or buckyball because it shapes like football or soccer ball. In soccer ball, if you know, then you will have multiple different 5-membered rings and 6-membered rings. So as we can see here, we have a 5-membered ring and it has covered with 6-membered rings. So this type of 5 and 6-membered rings will be repeated all along the shape, and all of these points represents carbon atom, and total number of carbon atom in this case it will be 60. This material also contain both type of bonds, that means single and double bonds, and their distances are 143.5 and 138.3 pm respectively. So these spherical shapes are also referred as buckyballs in short. Other than that, we have one more allotrope of carbon, which is actually a type of graphite. Because in graphite we have multiple different type of layers stacked on top of each other. If we can separate a single layer from the graphite, then it is known as graphene. Graphene has very mysterious property. Its strength is extremely high. It is very strong material. Even single atomic layer of graphene can hold a full weight of football, and it is very high. So that means if we can use comparatively thick layer of graphene, then it will have very lightweight and extremely high strength. No other materials have these type of high strength. In next lecture we will discuss about some important compounds of carbon and silicon.